from regenerative NOx removal.
My name is Alexander. I'm running a company that focuses on gas fermentation and emission gas treatment from different sources. Most of you spoke about ammonia as a nitrogen source. I will speak about nitrogen oxides as a pollutant in the atmosphere. And I will first explain the principle of our NOx removing process. Then I will outline some applications and also show you a couple of examples related to the regenerative NOx removing process. In general, as opposed to most of the presentations focusing on liquid nitrogen and solids, we have our focus in the atmosphere. We're trying to isolate, enrich, and regenerate pollutants, not only NOx, but also CO2 and other byproducts, and turn them into products, if possible. Now, a few words about the principle of regenerative NOx removal. Tatiana mentioned it already. It's as opposed to absorption not happening in liquid, but in gas phase. That's why it's an adsorptive process, which is based on the weak interaction between nitrogen oxides and the solid adsorber surface. As materials, we are using zeolites or alumina silicates, preferably. And the way of regeneration is not based on using liquids, exchangers, but we are using thermal regeneration. This means we're applying heat to desorb that weakly bound NOx. And NOx should preferably be also converted to a product at a later stage. The applications are wide. They're ranging from mobility via city air purification to exhaust gas purification, also needs in the mining and battery industry for different reasons. In case of cars, we have three-way catalysts installed and also SCR ammonia-based systems, but they're all destructive. As opposed to this, we are using the adsorber to especially buffer the cold start, which is linked to high NOx loads for both engine types, diesel and also petrol. The city air bears the consequences of all our emissions. Therefore, we have also developed systems for removing NOx from ambient air. The exhaust gas or the flue gas from different combustion processes is perhaps the biggest source of NOx, the biggest NOx load emitted at high altitudes. There we also have solutions I will show you in a couple of minutes. But also mining and battery industries have a need for NOx. Sometimes there is a nitrate component in minerals that is released during copper ore processing. In batteries, we have something similar. That's the negative side of the electricity or electrification. So NOx is also there emitted and can be used as a nitrogen source for products. A couple of examples. In case of cars, we have constructed a bypass in the car emission treatment section, which functions especially during the startup. Those NOx loads are emitted. Therefore, the whole NOx emission profile is significantly improved. Another application is city air purification, is mentioned, that was installed in the city of Heilbronn, Germany, in cooperation with Audi as our cooperation partner. And as you can see here at the bottom, the red peaks, they're more or less showing the real NOx emission in the air. The black one is the filtrate coming out of those absorbers. In essence, it will be 90% NOx uptake rate as a consequence of that. That NOx can be recovered and reused. Another example is reduction and reuse of NOx from industrial facilities, again based on the dual principle, adsorbing for removing and desorption for enrichment. As you can see in the top right graph, the inlet NOx concentration was in the range of 1,700, 1,800 battery ppm and could be reduced down to even zero for a while. Then, of course, increasing that's also the breakthrough curve. This enriched NOx on in that case, zeolite surface can be thermally regenerated by applying heat. And not only NOx, but also SOx or sulfur oxides can be regenerated in a similar fashion. In conclusions, NOx adsorption is a viable alternative to other NOx treatment methods, like using noble metals or using ammonia-based catalytic reduction installed in car system. This is more a regenerative approach. The applications are manifold. We can, apart from NOx, also reduce other pollutants. So we have a basis for simultaneous removal of other emission gas components. And at the core of all those developments, we have the circular economic principle to more or less use the byproducts and return them. That's it.
Thanks.